You can do
All right, guys, focus. I'm going to get into the rest of chapter 13. Let me ask you something before we can do that. How would you solve beautiful, right? It's the same idea. If there's a radical there, you isolate the radical. So you always isolate where your variable is. And then you do what you have to do to get the variable itself alone, right? So you would subtract 4. I like the fact nobody's telling me it's no solution, right? We were beyond that.
X minus 1.
No, you get it from what? I.
Plus or minus, thank you.
I'll do that later.
So plus or minus I?
I is true.
Good, because square root of negative 1 is I. It's do be me. Or it, I. There. And then to get x by itself?
Yeah, plus
Add 1. Okay. So I just want to say real quick, it becomes a general rule that wherever your variable is in the equation, wherever it's stuck, you get that thing by itself. Because I couldn't take the square root, this would suck. I can't do anything, it's a plus. I can't do anything if I try to take a square root right there. But I always get people that do, and they just make it x minus 1 plus 2. Yay! Well, that's crazy. Can you square root 13?
No.
Oh, I can make it 4 plus 9. And then that's 2 plus 3, and that's 5. Square root of 13 is 5. What? It's crap. Square roots do not play well with addition because they're based on multiplication. You guys with me? You have to be able to factor this, because then square roots work beautifully with multiplication. That's what they're built on. You guys kind of see what I'm saying? So that's why I can do this. Because 50 I can break up as
25.
Yeah, the multiple of two things. So then that can do that all day. It can't do a damn thing when there's a plus in there. It doesn't play well with that.
Only if there's parentheses around it. Would you do that? Like, if you gave us.
So there's a problem in what you're doing that has something like, let's see if I remember.
You can only do parts.
Some of you guys said it should look familiar immediately right now.
Pull out the 4.
Right? So I could pull a 4 out 4 times.
D squared plus 2.
I know I could pull a D out also, but can I take a square root of D?
No.
No. So I know this is 5 times 10. Why is that stupid? Why is that not good? Why did we do 25 times 2? Why did we do 5 times 10?
25.
Because I can't take the square root of 5 or 10. So here, I know I could pull a D out, but I'm not going to, because I'm going to do it based on what I can take a square root of. I could take a square root of that part, but not that part. What's the square root of 4? 2. What's the square root of that stuff? I don't know. Yeah, good. But that can't become D, because it's a plus there. Square roots cannot go and break into an addition. They don't play well with addition. How are we doing? All right. So you guys look very concerned. Okay. So, in the interest of time, we're going to do 13.5 really quickly. I'm going to make it extra credit just to make you feel less bad about going so quickly through it.
More extra credit.
Yeah. Let's not go crazy.
Eliminate 2.
Huh?
Wait, this is for homework?
Yeah. But real quick, I want to show you a couple examples. Now this is not what this section is about. This is old news. How would you solve this? Quadratic, right? And what would A be and C be? And you can throw it in and do all that stuff, right?
You can also do it to the
the squares.
Solving the square.
Oh yeah, you can complete the square so far. That's nice. All right. You can do that too. That's good. Especially because that 4 is divisible by 2, so complete a square is actually not a bad way to go when that happens. Good. But all the processes we use for something that looked like this, what's really important, the reason this is really quadratic in form is because the middle dude's power is half this guy. That's what's important. Because remember, how do you factor this one that I can actually factor? How do you factor that? X and X, right? To start with. I don't care about the rest of it at the moment. I know you can factor it. So that cut in half is that, and the middle term is going to come from that. That's why the middle term has to have half the first guy's power. So if I had x to the 10th minus 4x to the 5th minus 5, can I factor that?
Yes.
Because half of x to the 10th is
X5.
good. So if I made that a 4, not factorable, right? So to be quadratic in form, the middle power has to be half the first power. If that's true, you could use quadratic formula to solve something. Yes?
But if it's not true, what would you do?
You use a graphic calculator. Or you...
So what if?
Honestly. Right? If I made that a 4th power, there's not a damn thing you could do right now. There is some stuff you learn in pre-calc that you can maybe try. Right? But right now, we ain't got shit to do with that. Right?
But if we factor that, wouldn't that be 2 times? Like 5 would be just 25 power?
No. What do you do when you multiply? What do you do with that powers? Add. That's right. Okay. So, let me show you an example, exactly the way you would do it in this section, and then that's all I'm going to talk about because it's extra. I don't care. So if I had
X to the 4th minus 9 to the 2nd. X squared, yep, plus 8 equals 0. Or you just make it.
So obviously I don't want it factorable. So I want us to go past that. So if it's not factorable and the middle number is not divisible by 2, so I appreciated that. What do I want to use? Quadratic formula. And why do I know I can use it?
Because it's half.
Yeah, the middle power is exactly half the first. Now notice, if I use quadratic formula here, if I use quadratic, because I'm silly and I don't realize I can factor this thing, quadratic formula would say x equals blah, 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 blah. Right?
Yeah.
Because that's there. If I did factors, I have an x and an x and so forth. If I tried to do this one, quadratic formula would say x to the 5th equals negative b plus or minus blah, 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 blah. Do you guys see that?
Right.
The book talks about substitution method, which is not bad. It's not totally necessary here. Right? Now, if you like to use substitution method that the book talks about, you can use it. I have no problem with that. It's not really necessary. So for quadratic formula here, A is 1, B is maybe 9, C is 7. And I don't say x equals negative b plus or minus. I say x squared equals negative b. So let's put the numbers in there. So x squared equals 9, good, plus or minus square root of
9 squared.
negative 9 squared 81, minus 4 times 1 times 7,
28.
all over twice 1. So do you notice what this means? When you're done with this side, you're not done with the problem, because you figured out what x squared is. I want to know what x is, right? So the last thing you're going to have to do is square root. So you're going to solve for x squared. That's not what I want. I want to know what x is, right? You guys like this a lot. Yes, sir.
So is the square root to the square root going to come back to us because of
At the end, it's going to have to.
Alright.
If I know what x squared is, how do you know what x is? You take the square root. So just to finish this one out, it's been 9 plus or minus 53 all over 2. So the actual answer would be x equals square root. And what have I left out? So can anybody tell me how many answers are sitting there?
4.
Good. There's a positive that has 2 answers. There's a negative. So why does it make sense that there's 4 answers?
Because you have 4.
It's a 4th power swing. I was a little too excited about that.
It's a lot better
maybe,
than
maybe.
substitution method.
Well, either way, if you like the U substitution kicks ass a little bit later in mathematics. Here it's not completely necessary. And just to really solidify what the hell's going on, let me do the one you said earlier. And let's do it by factoring, because can you factor this?
Yes.
X squared. 1 and 8.
So when you solve those, you'll get x squared equals 1, x squared equals 8. I could have broken that up a little bit more, but I'm just trying to go a little bit more of what we're going to see here. This is the reason why when you do this, you're not done, because you're not directly solving for x yet. It's a 2-step process. Same thing that would happen here. Am I done yet? No, because I don't know what x is yet. So here I get x is plus or minus 1. Is that cool? And over there I get x is
Plus or minus 2 rad 2.
good. Square root of 8, which is 2 rad 2. You can get the word good out. Good.
It's not the same problem. Over there it's 7, it's 8 here.
I know, because I wanted to be able to factor. Here I didn't want to, because I wanted to force us to use quadratic. Here I want to show you exactly why you're not done. Because you have x squares running around. That x is running around. Right? Same thing, I got x squares running around. How many answers? 4. Which makes sense. Good. Right, so this is a 6th power. You better end up with 6 answers. Yeah.
So on the left, you can't factor it automatically, right? X squared, and then you do the quadratic formula.
Yeah, since the middle guy is x squared, and that is twice that, then you can just say x squared equals. So if there was a x to the 1/6 power here, what would have to be here?
Well,
All right, so let's try this out. So if I have, let me say this. If I have something plus 5x to the 1/6 minus 9 equals 0, what has to be here? X to the what power? For it to be quadratic?
1 to
1 to 1, 1, 2.
If this is 2, this has got to be 4. If this is 5, this has got to be 10. Twice 5, right? So this is 1/6, this has got to be 2/6, which reduces to 1/3.
okay.
You guys, so this would have to be 2/6 or 1/3. It's got to be twice whatever's there. So when I go to set a quadratic equation, I wouldn't write x equals negative b blah blah blah. I'd write x to the 1/6 equals blah blah blah, and that's all I'm going to say about that section. Because that's the idea.
That's terrible.
Graph. Yeah.
Are the extra credit problems going to be something like this?
Yeah,
Or are you going to
yeah.
make it more clear?
No. Make it like this.
Okay.
Yeah. I'll make them like this. Yeah. Okay. All right. That's awesome. All right. So 13.6. Now we get into graphing. There's been graphing kind of smattered through the other sections a little bit. And we talked about graphing to talk about the visual interpretation of 2 answers, 1 answer, no answer. Remember that? If the parabola just never comes to the x-axis. No answers, no real answers. You, Brandon? You're all right. So the first thing we talk about in 13.6, I want to kind of build up to it a little bit. And let me do something a little more direct. How do I graph this? Can somebody give me like what I call 3 anchor points for this? What are 3 main points that this goes through? 0, 0,
1, 1.
1, 1,
4
and negative 1,
1.
1. Good. So that captures the heart of this parabola. You with me? Because the most important point in a parabola, what do you think it is normally? The bottom, what's called, or the top, if it's down, if it's opening down. That's called the what? That bottom point is called, does anybody know what that's called? This point right there.
Axis of symmetry.
No, that axis of symmetry is what goes right through the middle of it. So it's kind of like where the mirror would go because it's symmetric to itself, right? The vertex. Good. That's called the vertex. That's called the vertex. That turning point is called the vertex. How are we doing right now? It's just a word. Okay, so here's where things get interesting. Like finally, how would you graph that? Let's kind of investigate it. Let's do some points here. If I plug a 0 in, I'll get 0. Yeah, what's 0 minus 1 is negative 1 squared is 1. If I put a 1 in, now it's 0. And if I put a 2 in, it's 1. So I get the, of course I did this out of order here. Let me do this in order. Give me a second. If I had done this in order, I could point something out that's kind of nifty. See how it gets the same outputs? But all the inputs are shifted over by 1. Do you see that? Why does it make sense? Whenever I plug something in, what's the very first thing I do to it? Take 1 away from it, right? So if I want to get the same answers I did here, I actually have to put in an x value that's 1 bigger. Because what's the first thing I do to that poor x value? Take 1 away. So if I want to get an output of 1, I can't put a 1 in. I have to actually put a 2 in. You see that?
Yeah.
I'll let you guys absorb that for a second. Because, if I graph this, let's just see visually what happened to my parabola. So I took that parabola and I threw a minus 1 in there. It's like, man, why? So, that is how they sound. So if I plot these, what do I get? 0, 1, 1, 0, and 2, 1. So, exactly, I love, oh, look at you, you're awesome. You used a beautiful word there. Just shifted over by 1, right? So you might look at this and think visually, you'd think maybe it would go back 1.
Yeah.
But the thing that you got to be careful about is if there's a minus 1 in there, all my inputs have to be 1 bigger to overcome that. So actually, whatever's in there is the opposite of what the graph does. So if I would have put an x minus 2, my parabola would have went chunk over 2. If I would have put an x plus 1 in there, it would have went back. Because now all my inputs can be 1 less than they were before. So this is shifting around. How are we sort of doing here? You're all loving this. Graphing is great already. Just made it even better. Okay. I want to give you a little bit of background to explain why we interpret the form of the parabola the way we do. That we're going to get to here in a minute. I want to make it make sense. What about if I do this? This is a very direct shift. Here's what it used to be. And now all my outputs are going to be, careful,
Over 1.
All my outputs are going to be 1 bigger than they used to be. Right? So it's actually going to lift it up by 1. Now real quick, I want you to really understand this right now. Because if you get into pre-calculus, you're going to do a shitload of this. Right? Which is a mathematical amount of stuff. It means a lot. When it's in with the variable, it actually does the opposite. When it's outside, she does exactly what it says. Because it takes what it was, 1 bigger. So the whole thing's just going to go up 1.
So inside is opposite.
Yes.
Without.
When it's with the variable. So watch, if I would have taken this over and made it this, see how it's with its variable now?
Yeah.
1 is with the y, so now it's going to be the opposite. It's going to go up by 1. So I don't know how much you guys are getting here. How important is it that you truly understand shifting by itself? Not extremely. I'm just trying to give you a little background as to why when I see this equation, I can tell you exactly what the vertex is without doing any work. So normally the vertex is at 0, 0, right?
Mm-hmm.
So where has it gone now? It went
Plus
Over
2 over, up 5. So where is it now?
2, 5.
2, 5. So the vertex is at 2, 5. Let me just let you absorb that for a second. If I would have just told you that, I'm sure that most of you would have been like, yeah, I had to give you a little bit of background, and you're going to do a lot more of this in pre-calc. For some reason, we actually don't do any of this in here. It's just stupid. How you doing so far? So now maybe, hopefully, you understand a little better why that's true. Now, what does it look like somebody might have done to the original equation to make that pop out? To make something squared? Maybe they completed the square. Good. Yay, another application of complete square. Yay. All right, you guys are loving this. Let me give you a couple lightning round problems here.
Just want to know where the vertex is?
Yeah, just where's the vertex?
-2.
No, say nothing. Good, because it goes back 5, down 7. Now, what do you think that all that -3 does is takes a parabola, makes it go down, and then it 3 times as quickly growing. It actually makes it skinny. So it's going to make the parabola go from this to this. Right? It's going to point down. But my vertex is always in the same place. I can find where it is in the same place. Where's my vertex? 4? 11.7.
You're just moving a bit faster.
Oh yeah, summertime. I started going fast. Can you guys, even if you didn't understand a damn thing I said about shifting, being able to locate the vertex when it's in this form is simple. Right? It's the opposite of this guy inside, and it's exactly what this dude is outside. But the more you understand shifting, the better sense it makes as to why that's true. Okay, go. So, if I have one, yes?
So really, to find the vertex, we only need to worry about what's inside and what's after, or?
Yeah, so the form of this we love the letters H and K for talking about like centers of circles or ellipses, focuses and stuff, or parabolic vertices, right? That's an awesome phrase. Might be a good band name. I don't know. Yeah, parabolic vertices. So here, the vertex would be at H, K. And all A tells you, if A is greater than 0, it's up. If A is less than 0, it's down.
And then the bigger the number.
Yeah, the bigger the number, the skinnier it gets. So if I had a 1/3 out there, it'd actually get fat. And this is sort of like slope in a way. It's almost like slope. It's in the right place for slope. Right? Y equals mx plus b almost. Don't do that. Don't think that's true, what I just said, because it's not true exactly. But this does act a lot like slope. So the bigger this number is, the steeper it gets. So that really translates to skinny. And the smaller this is, the fatter it gets, because it's going to grow really slowly. Okay, how are we doing so far? We're going to transition to the graphic calculator here in a minute. But I want to do a problem first, and then we're going to verify what it is we see. So what do I do if I don't have that form? I run screen.
So why don't you just pull and accept it?
So what you do, and yes, I do have another handout for this, which goes through 2 examples of doing this. That's what I said earlier. I tried to warn you guys that we're going there. So somebody, you see how I made room? So this is going to be interesting. I always think about Indiana Jones when I do this. No real reason. No, remember that scene, of course, where he's trying to put the thing there, he takes the golden statue. Have you guys seen Indiana Jones?
Yeah, buddy.
If you haven't, I don't know what universe it is. So take the little golden statue, put the bag of sand, he just didn't weigh it right, he goes to the boulder, blah, blah, blah. So if I'm going to add 4 here, I'm going to put that bag of sand on there, I want to also take that golden statue away. So if I add 4 right now, I better also subtract 4. So overall, what did I just do? Nothing. Like, way to go, Jeff. We could do nothing. But what I've done is I've collected all this stuff here so I can make it look different. It's not a different equation. Everything that's true about this is going to be true about this. The same equation because I just did nothing. But how do I factor this?
X plus 2.
And where'd that 4 come from? Make sure everybody's with me.
For completing the square.
Yeah, half of 4 is
squared.
2. And then 2 squared is 4. So it needs a 4 there. And the 2 is how it factors, right? So what's the vertex?
-2, -6.
All right, so let's do this. Let's go to the graphing calculator. I've got a few up here if you want to borrow one.
So why is it on this completing the square we're subtracting it instead of adding it versus before we were adding it?
Because we were doing the same thing to both sides to make it equal. So again, remember the balance. Think of a balance. If I put 2 grams here, I better put 2 grams there to keep it balanced. Or if I put 2 grams, I could also take 2 grams away and it's still balanced, right?
Gotcha.
So if I'm working on the same side, I have to do the opposite thing.
That makes sense.
Add 4, but it's simple. Yeah. Now technically you could just add 4 to the other side, but I desperately want to keep you guys away from that because that side should just be f of x or y. It should always be that. We need to be used to doing this because you actually have to do this kind of thing later. There's no way around it. So, yeah.
What did you do with the x squared?
How do I factor this?
Oh.
X plus 2 squared. So I still have x squared. It's there. It's just condensed. So let's put this in the calculator how it looks originally. So what I mean by that is put in there x squared plus 4x minus 2. Okay, cool. And then graph that bad boy. Can you guys see that all right?
Yeah.
Now, just eyeballing it, it looks like it's -2, maybe that's -6 if I felt like counting. You with me? So it looks like it's what we got, but let's make really sure. How can I find out exactly? You could trace it, but that sucks. As you find out quickly, that's never going to be exact. How can I find out exactly what that is? Go to second, trace, because I want to calculate something. And what do I want to calculate about that? Minimum. So I can't remember if we've done this yet or not, but the minimum, what I try to tell students, because sometimes left and right's a little weird, get right on the answer and then hit the left key several times so you're on the left bound. Trying to give this thing a little area to search in. Got it with me? So go to the left of the answer. I'm a little left of the answer, enter. Then go to the answer and past it. Go a little right of the answer, enter. And see how it opens these little arrows here? So it's going to search in between there. And then get right on top of the answer, enter. Did anybody get something a little different than this?
Yeah. I got -1.9999.
Beautiful. So when you see that, the calculator's desperately trying to tell you it's -2, right? But some of you guys might see -1.999, or you might see -5.99, or -6.00001 or something. It's because the calculator gets to a point, a certain tolerance, and it stops, or it's the resolution of it, right? So if you have a TI-82, that happens a lot to you because they don't have a lot of processing power, right? Not to pick on you or anything, but your calculator sucks. No. Mine, of course, is using the full power of this computer, which is just awesome. How's that? So if I had a downward-facing parabola, to find a vertex, I have to find the maximum. There you go. And that might be like a profit function, right? Here's my profit function. We want to be there. We're there. How do I get there, right? You guys semi with me?
So we just start typing in the calculator and finding our answers every time?
What do you think? I like that. No, you could, but then you fail. Okay. While I'm here, I can't remember. How do I find on here? How do I find these X-intercepts? How would I find that X-intercept right there? Not. I don't have two functions here. I can't find where two functions intersect. What does the calculator call this this X-intercept?
Zero.
It calls it the zero. Because the X-intercept is where the function's output is 0. With me? How do you find the X-intercept? You make Y 0. So it's the 0 of the function. It's where the function's output is 0. So if I go to that one, it'll ask me 3 very familiar questions. So if I want that intercept, I go a little bit left of it. I go a little bit right of it. And then I go right on top of it. So there's that beautiful little intercept there. And see this number here? What's that number? What does that E mean? Somebody know?
It's like the decimal places.
Sort of, yeah. It's a scientific notation.
Yeah.
So it's like times 10 to this. This is -1, and then you go back 12 times. So what do you think the calculator is trying to tell me? What do we know Y is supposed to be there? 0. So this is really close to 0. That's that resolution problem. It gets really close and then stops. So if you see this E -12 or E -8 or E -20 or whatever,
Put 0.
it's trying to say 0. Especially for us. Later, that actually might be the answer. But for us, that's 0. Okay. So those are the kind of things you might have to do in the calculator. Find the vertex, find the intercepts, right? Okay. The Y-intercept is always easy. Can anybody tell me what it is just by looking at the equation?
-2.
Yeah, how do you know it's -2?
Because it's the C.
Yeah, because what do you do with X to find the Y-intercept? You make X 0. So if I make X 0, Y is -2. So -2 is the Y-intercept. So I almost never need calculator help for that. Just make X 0 and I'm good. Okay. How are we doing? Okay. So let's try another one that's a little bit harder, and then I'll give you the handout to look at.
We're just graphing or?
We're going to find the vertex. Yeah, we might as well try to graph this one by hand. See what happens. It's going to be all kinds of fun. So let me go with you, because this is a little bit harder. Why is this one a little bit harder? Yeah, because completing square requires
X or A to be 1.
A to be 1, and it's not 1 here. So I can't divide both sides by 3 because I don't want to mess with my Y. So all I can do is I move the 5 a little bit over, get that out of the way for a minute. Just let him hang out. And then out of here I can take a 3. Don't take an X out. I know I could, but the whole point of it is to leave something like this so I can complete this guy's square. I just move the number out of the way. Because here, did I take an X out of these two? No, I just started completing the square because that's a 1 already. So if I can make it a 1, then I can just do the same thing we did here. How are we doing so far? All right, so if I take a 3 out of the way, I can complete this guy's square. So of course, what do we, careful. Careful. Half of -4 is -2. Squared is +4. You'll always add something here. Always. Because it's coming from the square. And we're dealing with just real numbers there. So here it's got to be +4. Now out here, what I do, -4?
Yeah.
Do you see how I asked that question? It's probably wrong. That is a mistake. I did not. You're all going to be worried about my meds again. I did not just add 4. I didn't. I added 12. Because if you multiply that back in, don't you get 3x squared minus 12x plus 12? So whatever number's here, you have to take into account with what you just did.
Why?
So what do you have to act?
Minus 12.
Because you're already at that, you already broke down at that step. Why are you having to worry about what it would have been when you already, it should be correct?
No. That's what it is. I'm worried about what it is. So if I add 4 in there, I actually just did what to this equation? I actually just added 12.
Yes.
So what do I have to subtract to keep the balance? 12.
You gotta remember.
That's the key, right? I'll let you absorb that for a minute. That's obviously a really easy mistake to make.
But you're erasing the 12, aren't you?
What do you mean?
After you put it into the x, well, 3.
Well, it's still,
Three
it basically
times
becomes
x minus
3
2, so
with,
plus 5, right?
yeah, the x minus 2 squared, and then it becomes
Yes,
minus-
now on the next step, I'm not sure what you mean about erasing 12, but on the next step I have 3 times, how do you factor this?
X minus
Minus
x.
2.
And then what do I have out here?
Negative 7.
So you still want that there.
Yeah, it's what's there. You don't have any choice. Yeah, definitely not. Can you guys tell me the vertex right now? What's the only thing that this positive 3, what 2 things does it tell me about my parabola? It's up and it's skinny, right? Right. Well, that's good for it. So the vertex here is, tell me again, 2, negative 7. 3 doesn't matter at all. I got it out of the way in the first place, so I can really see what's inside, and that's what tells me the vertex is. So if I go to graph this, here's what's really, really, really cool. And you're like, I don't believe anything could be really, really cool about this, but try it. Do you want to find the X-Intercept? Can you imagine that they're easy to find?
No.
Not really. You could actually set this version equal to 0, add 7, divide by 3, take a square root, all that kind of crap. But I want to show you something. If I just ask you to graph this, you can use the fact that parabolas are symmetric. If I know one point on this side, I know its mirror image is on that side. Let me say that again. Parabolas symmetric, right? If I know this point's there, then its mirror image has got to be over there. And they have to be the same distance away from the vertex. So the vertex is right in the middle. That's going to come back in a minute to help us with something else. So the vertex is at 2, negative 7. What's the Y-intercept?
Negative 7. Oh,
Careful.
Plus 5.
Yeah, you always got to go back here. If you plug a 0 in here, you don't get 0, you get negative 2 squared, and blah, blah, blah. Always easiest to see the Y-intercept when it's in this form, because you plug a 0 in for X, you're left with whatever that number is. So my Y-intercept is 0, 5. 1, 2, 3, 4, 5. So how far over is that point away from this mirror line?
So it's going to be 4, 5.
This is called my axis of symmetry, not axis of evil. Axis of symmetry is just where your mirror would go. It goes right through the vertex, because what's right in the middle? The vertex. So how far away is it from that? So how far away does the mirror image have to be?
2.
It's got to be 2 away from the mirror, or 4 away from the other point. So 1, 2, so that I know there's another point there. How much work did I have to do for that point? Barely any. It just had to reflect it. Do I need the X-intercepts to graph this thing?
No.
No. I'm going to kind of pick them up sort of as I draw this, depending on how well I draw this. So my X-intercepts are somewhere there and there, right?
Somewhere.
How can I find them exactly? Quadratic formula. I could do that to this, right? Or I could set this equal to 0, and that's actually almost solved, yeah. How are we doing so far? Yeah.
Are you going to be asking for the X and Y intercepts on some of these questions?
Yes, totally. So try to graph that and see if it comes out looking the same.
Yep.
Yeah, sorry.
So you use quadratic formula on the original one or the one that we?
So we'll do a problem. Actually, we'll do it on this one. Why not? Let's do this. You guys have the graph in there? Let me catch up to you. Go away. Let's see. 3x squared. What was it? Minus?
Minus equal of x plus 5.
Of course, I'm not. No, it's okay. I can do that. So we could find the vertex. We can verify that the vertex is 2, -7, right? I have to use the what function?
Minimum.
Minimum. Cool. So that's are you guys cool with that? Do you need to see that again?
Yes.
All right. Let's do that one more time. Let's see. Second trace to get into calc. Anytime I have to calculate something from my graph, I go there. Right. There's some calculus stuff down here, so just stay away from them. We want a minimum. Since ours opens up, we're going to have a minimum. So I'll do number 3.
Come on.
I'm right here. And then you go a little bit left of the answer. So for the left bound, you go a little bit right of the answer for the right bound. And then for your guess, you get right on top of the answer. And see here? Here's a good example of where my computing power was not enough. It's trying to say 2, but it just resolved it this close. And for me as a human, that's pretty damn close. All right. How are we doing so far? Now you all, if I'm out there, I'd be like, this thing costs enough money. You should get the right answer. But just deal with this today. All right. Now, let's find the X-Intercepts. Here, some of you guys find the top one, and some of you find the bottom one. So that half of the room find the lower one, and that half find the higher one. Let's see what happens. And then some of you guys like, sure, yeah, I'm just going to wait and see what happens. So do the 0. So let's see.
4, 7.
A little bit left of the answer. A little bit right of the answer. And right on the answer. Yeah. So if you're doing it, you should get this for the lower one. Yes, sir. Oh. You got to be real careful about left bound, right bound. So what happened is,
The thing is, if you get too close on these, that's fine. You gotta open up your gap.
Oh, really?
yeah. So maybe left bound, go that far. See where the cursor is?
See, because I was trying
Give
to
it some more room left bound. Give it some more room right bound. Yeah.
I was trying to speed up the computing, but keeping it closer.
Oh, I see. Sometimes you're close and you're actually on the other side. So what it means by no sign change is it all stayed in the positive part. So just be sure that one's negative and one's positive. You go kind of far away.
Wow. Okay.
So that's what I meant by the no sign change. So sorry, what did you guys get for the other?
3.5.
3.5 something?
Yeah.
Flush?
3.5275.
Sweet. So you got that. So of course I did not write down. I want to keep track of these. So we got 3.5275, blah, blah, blah. And well, the other one was 0.47? 2, blah, blah, blah. Okay. Now, let's calculate by hand what the X-intercepts are. Just because it sounds really fun. And we'll do it 2 different ways. Just because once is not fun enough. So, one way to do it is straight up quadratic formula on this guy. All right, I'm going to go all quadratic formula on this.
12 plus or minus.
Good.
Minus 4 minus times 3 times 5.
Right, so b squared minus 4ac.
You just went to Boston and came back.
I totally did.
Squid.
Man, Quinby. Ask not. as you know. Okay, so then you get 12 plus or minus square root of 144 minus 60.
84.
And you could simplify that radical, but somebody else, what's 12 plus rad 84 divided by 6? Somebody do that in your calculator. You got to do that. Be careful. Figure out what that is. I want to compare it to our decimal, right? And then, of course, 12 minus rad 84 divided by 6.
3.527 for 12.
For this one? Yeah, 3.527. And then the other one hopefully is going to be 0.47. I mean, nothing amazing there. It's got to be the same damn thing, right? We're just doing by hand what we just did in the calculator. They have to match. The calculator's always going to give me decimal. So if I want to check my work, I'm going to have to actually figure out what that is as a decimal.
So for our answers in our homework or test, you want us to probably round like 3 decimals out?
If I'm asking you to graph it using the intercepts, you're going to want to make them decimals.
Okay.
If I just ask you what they are, and I don't say what form to put it in, either way is fine. Right? But I need to see the work that got you there, because you can get it from this guy, but that's not good enough. The other way to solve this, to get the same answers, are to start here and set that equal to 0.
And you get the same answers.
And of course you get the same answers. You add the 7, you divide by 3.
2 plus or minus.
Are you guys semi-good with this? You see what I'm doing?
Yeah.
So I can use this form, like we just did, set it equal to 0, quadratic. Or I can use this form, which is completed the square already. Right? So then I can set equal to 0, add 7, divide by 3, take a square root. Add 2, so I get this. Which, believe it or not, is the same thing as this. If I simplify this, the 6 goes in 6 into 12 is 2. Some stuff comes out of here. Simplifies down to that, believe it or not. So if you put that in the calculator, you get the same answers. How are we doing so far? So either way to find x-intercepts by hand. Either quadratic on the way it gave you, or just use this form directly. Take a square root after you get the square isolated. Yeah. Y'all are so grim. Why? Okay. All right. So there is a, you know math does this all the time. You know math teachers love doing this to you. We have a long-ass way to do something, and we have a shorter way to do something. You're going to have to do both on the test, so don't get all excited. So, but I want to show you a shortcut, because this is not necessarily horrible to do, but if I didn't have to do this, that would be kind of nice, right?
Yes.
Okay. What did I say about the vertex in relationship to any 2 points across from each other?
Mirror.
Good. It has to be the same distance away, right? Okay, okay. So, if I gave you a problem like this, stay with me. What are the x-intercepts?
2 and 5.
2 and?
-5.
Okay. And does this thing open up or down? If you did multiply it out, would the x squared term be positive or negative?
Positive.
Positive. So it opens up. Right? If I put a negative out here, it opens down.
What's that for between -5
The vertex has to be on a line on that axis of symmetry that is directly in the middle. It's got to be somewhere there, right? The vertex has to be in the middle of any 2 points that are across from each other, because there's mirror image from it.
So you just
We just used that in reverse a minute ago, right?
So you just use the midpoint formula?
Or yeah, but they're across from each other. You don't have to do that. They're on the same axis. You could just figure it out directly. How do you average -5 and 2? And so -5 plus 2, -3 divided by 2, 3 has so 1.5. So -1.5. The vertex has to be. The vertex is not there, right? That would be an incredibly fat parabola, the fattest possible, right? But the vertex is somewhere on that line that's in the middle. Are you guys? That's the mirror. So how do you think, if I know x is negative 3/2, how do you think I find out exactly where that vertex is? Find out what x is. How do I figure out what y is? Thank you. I just plug it in, right? So if I know what the x part of the vertex is, and how do I know that the x part of the vertex has to be this? Because the vertex has to be in the middle. Right? If I told you there's a parabola here and these points are across from each other, where's the vertex got to be? Somewhere on this line right in the middle. Maybe there and it's opening down, maybe there and it's opening up. You guys kind of with me? It's got to be on a line in the middle. That's symmetry. You're using symmetry. It's awesome. So if x is negative 3/2 is the x part of the vertex, how do I find the y part? Plug it in. Right? Oh boy, you guys love this show. All right. So if all right. If I told you there's a parabola here, and one x-intercept is there, and the vertex is here. Can you tell me another x-intercept?
-3.
Yeah, how do you know?
Because it's just 2 over.
How far away is that x-intercept? 2. So how far away does the other one have to be on the other side? Mirror image, right? It's got to be a mirror image on the other side. Why? Because parabolas are symmetric. Come on, guys, stay with me. Parabolas are symmetric. So if I know something about that side, the same damn thing is true about the other side, because it's symmetric. So if I know there's a vertex here, an x-intercept there, there's got to be an x-intercept there. Now just think backwards about what I just said. If I know that there's an x-intercept there and there, where's the vertex have to be?
Right in the middle.
Somewhere in the middle. Somewhere right in the middle, but I don't know exactly where on that line until I plug that point in and see what the y is. See where it is. Actually, I know it's got to be somewhere down here because I know this thing opens up, right? I just don't know where down there. So if I plug a negative 3/2 in, I'll see what the y is. I just had to pick fractions here, didn't I? So negative 3/2 minus 2, and negative 3/2 plus 5 equals something or other.
-12.25.
Stick it.
-12.25.
12.25. So negative 12.25 is the vertex. Okay, now, stay with me. This gets better. You guys are like, it has to, Jeff. I love the look on your faces right now. What formula do we have that will always give me the x-intercepts? What formula do we have that we can find the x-intercepts for anything? That was factored already. What if it's not factored already, or it's not even factorable? Quadratic formula, right? So, I love you guys. You're all right now. You're saying this is not looking better, dude. This is getting worse. But stay with me. Can I write this like this? Do what you want to, man. This is actually a place we got to when we derived this, and then we put them together. I don't know if you, so I can certainly tear them back apart. Now look at what this says. The two x-intercepts are at negative b over 2a plus this, and negative b over 2a minus the same thing. So I have an x-intercept here, and I have an x-intercept there. So, and then what this says? What's right in the middle of these two intercepts? Negative b over 2a. How do I know that? How do I get to this intercept? I don't do negative b over 2a plus this. Right? Don't I get... That's the bigger x-intercept. How do we get the smaller x-intercept? Negative b over 2a minus this. So if the two x-intercepts are always going to be that plus that, that minus that, where's the vertex always going to be? Negative b over frickin' 2a. That's the ultimate shortcut. Stay with me. Let's do some concrete examples, because you're all still like...
And that is the vertex, correct?
I'll just make this easy. Yes, because it's the one that's in the middle of the two x-intercepts. How do I know it's in the middle? Because it's what I add to get to the upper one, and it's where I subtract from to get to the lower one. So what's got to be in the middle? This stupid thing's got to be in the middle.
But that's just the middle.
That's the middle. That's the X part of the vertex. So how do I get the Y part of the vertex?
Then you plug it.
Plug that in. So let's do the one we just did. Actually, let's do an earlier one. What was that? What was that one we just had? 3x squared plus 12x plus 5. Is that right? This is the one we just did,
Yes,
right?
that's the one.
So let's use the shortcut. How do I find the vertex?
So 12.
X is negative b over 2a. So what's b?
Negative 12.
Negative 12. So it'll be negative negative 12. So it's 12 over twice a. What's a?
3.
3. 12 over 6 is 2. Now look, is that what we got for the vertex?
Don't remember.
Yes.
Yes.
But that's
I
just
think it's right there. It's 2, negative 6. You with me? 2, I think it was negative 6. Negative 7. Okay, so close. That, how long did that take?
A lot less.
Yeah, right? That's why we call it a shortcut. So the vertex, the X part is 2. How do I find the Y part?
just plug it in.
Plug 2 in. So the Y would be 3 times 2 squared minus 12 times 2 plus 5. 3 times 4 is 12 minus 24 plus 5. Negative 12 plus 5 is negative 7. There's the Y part, right?
Whoa.
And again, it all came from the fact that if I know the 2 intercepts, the vertex is right in the middle. That part by itself, you should all be able to accept and handle. The vertex will be in the middle of any 2 points that are crossing each other because it's symmetric. So what equation gives me any x-intercepts anywhere? This one. Well, what's in the middle of what this guy says? This is. That must be then the x part of the vertex, based on what we just said. It's got to be in the middle. So any quadratic I give you, you can find its vertex stupid fast. Right?
Should be.
Should be. So what if I give you... Holy crap, what did I do to this board? I made a point somewhere. Let's find the vertex. Can you imagine completing the square on this dude? Just imagine it for a second. You'd have to take a negative 7 out, so you get a negative 5 over 7 there. Half of that squared. Can you imagine doing that?
No.
No.
No, you're gonna actually live that experience maybe, but let's not imagine for the moment. What's the shortcut tell me? How do I find the vertex, the x piece? Negative b over 2a.
7 over.
Negative 5 over twice negative 7, right? So it'll be 5 over 14, the negatives cancel. Right? Ooh, it's a fraction, who cares? You got a calculator, throw that thing in. So f of 5 over 14. Let me show you something kind of cool here. Right, you just throw that in. You just throw it back in to figure out what the y piece is. So let's see, what do we get here? I'm going to show you something kind of cool that I don't think I've shown you guys yet. Negative 7. So negative 7 times 5, times 5 divided by 14, and that whole fraction squared, plus 5 times 5 14ths. Where'd it go? Plus 11.
Don't you need to put that 5 times 5 14ths in parentheses?
No, I don't, because order operations is cool with that. This one I have to put in parentheses here, because if I don't, I'm just going to square the 14. Good Lord, this takes forever to get over there. This here, if I don't put in parentheses, is just going to square the 14. I'm telling it, oh, let me do it. I have to tell it to square the whole thing. So I get this. Oh, I don't know. Let's see if it can handle this. It's going to show you something kind of cool. Now I'm worried. Just, yay! I don't know if you guys can see. Look what I just did.
Second what?
Math.
Hit math, and the very first thing it says is arrow fraction. That means convert to fraction. hit enter, it takes the last thing on the screen, makes it a fraction if it can. If the denominator gets too big, it can't handle it as a fractional form. You with me? That's huge. And you're all like, why didn't nobody tell me that in Math 88? Because there, we don't want you to know. That's cool. So if I want an exact answer, you can do that. That's awesome. We're ahead of it.
It's time to go. About time to go.
All right, so let's see. Let's do one problem all the way out, and then maybe we'll head out.
So is this still 13.6? This 13.6?
No, we've bled into 13.7 now. They all kind of overlap, so. So the form this is in right now, can somebody, what can we see immediately that would be helpful for graphing?
It goes down.
I like it. So we know that this opens down. Well, it's going to be skinny because it's like a large slope. So it's going to grow, or in this case, grow negative. It's going to grow quickly. So it's going to be skinny. If that was 1/6, it would be fat because it would grow very slowly. And the one thing that I know immediately, directly, what else do I know?
Y.
Yeah, the Y-intercept. 0, -1. The x is 0, so the Y-intercept is -1. Okay, how are we doing so far? Doing awesome. Okay. How do you find the vertex using the shortcut? Yeah, so x equals -b/2a, which is -24 over twice -6. I like it, right? Yeah, 24 over 12 is 2. So what's the y piece? Just throw it back into the function, right? Once you know x, put it back in the function, get y. So -6 times 2 squared plus 24 times 2 minus 1. So 23. So the vertex is where?
223.
223. I love it. So this is all we need. All we need is the vertex and any other point. That's all we need, because then I can get, I need 3 points though to get a parabola. I do. But once I have the vertex and in 1 point, I can get the other point by symmetry. So to graph this thing, I need to get up to 23. So on my scale would maybe be 5, 10, 15, 20, 25, 30, okay, 10. Jeff, what do you do? So my y-intercept is 0, -1. Remember, this is by 5s. Oh, crap. So this is -5, so -1 is like right there. Because of the scale I chose, it's not going to look skinny, but don't hold that against it. Where's my vertex?
223.
223. Cool. So can anybody tell me where one more point would be? How we doing? What's up?
Well, you've already got your y-intercept, so use that one.
I need one more point beyond the 2 I have.
So then it would be
-3.
Yeah, so this is 2 away from the axis of symmetry, right?
Right.
It's 2 away, so another point's got to be the same height, 2 away. Mirror image. So it'll be 4, -1, right? That's 0, -1. The vertex is on the at x equal 2. So another point's got to be Same distance away on the other side of the mirror. And that's plenty. Now I got everything I need for my graph pop. It's not too bad, yeah. You can imagine, if I blew this up to 1, 2, 3, it would be really skinny coming down. Yeah.
How do we know that it opens down?
Because of the negative.
Oh, so
In front of the x squared term is a minus. It's sort of like mx plus b. If m is negative, it's going down. So if that first term for the x squared is negative, it's going to open down. Exactly. Cool. Well, you don't even have to go into this knowing that. When you do the work, the vertex is above the y-intercept. Then it has to open it. But it's kind of good to go in knowing that, so you know that you're on the right track. Okay, so look for an email from me with the practice test at the latest by tomorrow or Friday.
And you said 13.5 is bonus, right?
13.5 is extra credit. And we will talk about 13.8 before we do the review on Monday.
So we're skipping 13.7
No, we just did 13.7.
and 6.
Yep, we sure did.
That's awesome.
They're both about graphing, so I just graphed everything all at once. Yeah. No, turn those in. Your group work. Oh shit, I missed everything up there. Sorry, people at home. Huh? Same thing, yep.
You looked up and you're like, where the hell am I?
All right.